Me too.
Yeah, I see it here too. Yeah, we can see it too.
Okay, so Pat, you're not seeing it?
Well, no, but we'll look here, see if we can figure out why.
You're looking at your browser. Pat, typically that would be because you're looking at your browser and not actually at the GoToMeeting app.
Yeah.
So because the browser window will continue to show something saying GoToMeeting, but there should be an app open as well that has the right screen showing.
I got it. It disappeared.
I can't even hear him.
I can't hear Tom right now. Can others?
Nope.
No, I can't hear him either.
Can you hear me now?
Yeah.
Yes.
Yes.
Now, now I'm getting a little bit of an echo. Does that sound okay?
Yeah.
Sounds good on this end.
Okay, so I said some really important stuff that everybody missed, and I'm not going to repeat it. But
Chance to hone the message.
So I'm going to go through an example in GiST that shows how the structured decision-making approach is basically programmed. It's a lot to go through, so I'm going to probably go pretty quick through the different tools in GiST and show how they are pieced together to form a structured decision-making approach. As we've kind of gone through before, we've got 5 steps, and what you'll see on the left is a navigation panel with 5 steps. These include understand the context, define objective, develop option, evaluate option, and take action. Do I sound okay? I do hear an echo, but okay. So the first step, understand context, as we've talked about before, is just collecting information on the decision landscape that you're dealing with, and this is the political, regulatory, social, and institutional setting. We have, this is a fairly qualitative step. We do have some tools to allow you to document the decision landscape, so you can basically start building a document with these little editors. These are WYSIWYG editors that allow you to input information, store information, and you can create new tabs with new types of headings, and basically save this with your project. We've got a couple other tools, including a systems thinking tool. This one's called System Sketch, and it's a standalone tool that also lives in GiST, and it allows you to go through your the basic issues with your project and define basically the system model that might need concepts that might be needed to be included in your project. So, for example, I've clicked on agriculture, and then it's got a bunch of links that include, say, non-point source. So you can basically build a conceptual model in some sense using this tool. So there's a lot here, and these diagrams get pretty crazy. But so this is just one of the tools under the understand context. Another one we've worked on is a social network analysis tool. And this allows you to do a website social network. So it allows you to search related websites and connect, basically build a network. And so, for example, I can enter a URL for this is Narragansett Bay, save Narragansett Bay, and do a search, and it finds related websites. And you can keep basically what they call snowballing it, and continue to build out an organizational network based on websites. So these are the two of the tools in the Understand Context section. The next section is Define Objectives. And one of the recent tools we put together is a brainstorming tool. And this is really designed to facilitate elicitation workshops. And this allows you to input any ideas that are coming up from stakeholders. So might have meet the budget, and then you can classify these, assign these to different types of categories of issues. So I'm going to make this an objective, and this is a little bit of guidance about what an objective should be. And I'm going to make this a fundamental objective, and then I can categorize other things by moving them close, and you can kind of group things. So I think these are stakeholders. The brown are stakeholders. The red are regulations, and we have a whole category of different types of ideas. So these end up going in what's called the parking lot, and then you can, when you go to developing objectives, you can go to your parking lot and you can drag these issues over and help start building your objectives hierarchy. And so that's the basic step in Define Objectives, is building out an objectives hierarchy. And so for this particular project, we were looking at whether we could remove 3 air stations from the monitoring network at Hanford. And we identified some fundamental objectives: maximize social sustainability, minimize health impacts, minimize environmental impacts, maximize flexibility, and maximize the economic sustainability. For each one of these, we identified measurable objectives, which are then directly tied to measures. So for maximize public assurance, we developed a constructed scale public acceptance measure. So that would be something like a survey where you're trying to get a sense for the public acceptance. It's got a categorical value function that goes from very poor acceptance to very good acceptance. Very good has a high value, very poor has a low value of 0. Another one would be cost. So we've got basically we're going to try to minimize the cost of the monitoring program, and we have a value function that is editable, and this allows you to basically change the value function for cost. So normally these would start off as linear, and you can go in and play with them. You can actually edit the values directly. But the idea here is you're trying to come up with objective measures so that, and these would be the things that will go into your conceptual model. That
hey, Tom, we lost you again.
So nobody can hear me? Can anybody hear me?
We lose everybody.
I hear you just fine.
We can hear you too.
Okay, it must be a.
It's on too.
Must be an England thing. Okay, so that's.
Like Tom's still talking.
Yeah, I'm still. We've got a little construction going on here too. Okay. Now that we've developed objectives and measures, we're going to weight those measures. And so this is under the objective preference tool, and this allows us to rank our measures by dragging them up and down. So I'm going to put cost as our most important measure, and getting the fee is the second most. And then once we've got them ranked, we're going to then start at the bottom and do a swing weighting. So I can go through each combination starting from the bottom, provide a relative preference for each one of these. And that develops a weighting scheme. So here we've got the weights that I've just input by this relative preference. So these weights are going to be used in the scoring for the measures. The next step is then to define options, and again, the options are going to be directly connected to the fundamental objectives. And so we have a very similar interface to the objectives tool that we have to the define options tool. So each objective is going to have a set of options associated with it. For example, one of our objectives is to detect unplanned releases, and one means objective for that might be maximize monitoring. And so our options here are to move stations to a power grid. There's a power line that's potentially is dying, and they either need to replace that to power the monitoring stations, or move the monitoring stations. We could make them solar powered. So there are several options for each of these objectives. Once we have options, then we collect those into scenarios. Let's see. So one of the scenarios is going to be replace with solar powered stations, and so basically we're basically zeroing out all the other options except for solar power. We're going to remove 3 solar power stations, and we're also going to remove the power line. And so we've got several different scenarios that we're going to look at, which are just combinations of those options we've defined. So now we have a set of measures that are connected to options, and we need to evaluate those options. So this has been set up in the BaseNet tool, and what we have is options are orange, yellow, measures are the green, the red or models or stochastic inputs. So for example, we have the probability of an unplanned release. True is 0.1, false is 0.9, so it's very low probability of an unplanned release. That's going to go into a detection model, whether we actually detect that release, and that feeds into public acceptance and the measure of whether we have undetected releases. Each one of these options feeds into a sustainability score, and this is a DOE sustainability score. Each one of these has some cost implication. Each one of these has, well, they have a flexibility implication. If we look at the cost model in this BaseNet, we can look at the different combinations of and the costs associated. So this is the cost here, 0 to 0.05, and then on up to 0.5 to 1. And this is broken up based on the value function. And the idea is you go in here and enter a probability that given the set of options that you'll have that that cost. So for example, if we don't use TDLs, we don't replace the power line, we don't move the stations to grid, we do remove the power line, and we have 3 solar power stations, the probability is 1 that the cost will be between 0 and 0.05. So these are the conditional probabilities that you have to enter in for each of the combinations. So you have to develop these conditional probability tables for all these connections, and then when you run it, the basic output is a comparison of the scenarios. Here we see replace with solar power stations is the winner. It's got the highest expected value and by a fair amount. And you can see the breakdown from how each of the measures adds up. So you get a great deal. So replacing solar power stations has a minimum cost, so it gets a high value for cost. They all get about the same. Well, it's pretty good for detecting releases. It's good for flexibility because you can move them around. And this just gives you basically a ranking of those management scenarios. We do have an adaptive management tool. It's not, we haven't gotten to the point for this project of setting up an adaptive management, but the idea there is that you can, let me see if I can pull up a project. So this is the type of thing we do in adaptive management, where we look at these measures, we define a trigger date and a trigger level, and then we're collecting data over time. And you would hope at the trigger date you would be meeting the trigger level, and in this case this indicates we haven't met that and maybe should take some adaptive management actions. But this is the type of thing we do with for adaptive management. So this is the conceptual model for adaptive management, or for this particular project. And you can associate data with a node and then associate triggers. Just to show you kind of a different look at this. So one thing we've been playing around with is changing the steps to do more of a prioritization type approach. So just in this case, we've reduced the steps to 3 steps to develop alternatives, to develop criteria, and prioritize. So we've changed the language a little bit. So we're playing around with how we can change the language to best speak to the particular audience. And then let's see. Again, we've got a BayesNet set up to do the prioritization, and this is where we're looking at cleanup for national parks. So in this example, we've got three parks that we're trying to prioritize. They have different types of wetland area, different contamination types, different areas of contamination, and criteria like park prominence, how big it is. And so we can run this, and this gives a prioritization for the parks. And so Park 1 wins mostly, it looks like, because it's a very prominent park, so it might be Yellowstone or something like that. Yeah, so we're trying to look at different ways to present this information and different workflows and user information for different types of projects. So that's kind of the basic set of tools. The way SDM is implemented in GiST. So are there any? I know this is pretty quick, and there's a lot here. Does anybody have any thoughts or questions?
Tom, I have a question. If you go back to the conditional, in any of those examples, you go back to the conditional probability tables.
Okay.
So earlier on, you've got objectives and criteria and measured values and everything. So then this is where you put in the data from for example, the data from the parks I put in here, I hand put it in. Is that
right? Right. So here, let's see, for example, here we know Park 3 has a wetland area between 0 and 3.95 hectares. So we know that. We're less for Park 2. We're less certain about how many what the wetland area is. So we've split it into two different categories. And then Park 1 has the highest wetland area, and we're pretty sure it's greater than 7, but we're not really. We could be less than 7 hectares.
Okay, so in a prioritization scheme where you have data for maybe 400 of these parks, it would get fed in here somehow? I mean, is this where it would get low?
So that's something we'd need to work on as a better interface, because it would be hard to enter this information for 400 parks. So that's something we can look at as a better, basically you'd want to upload information. And I can think we can develop an interface that would ease that, I think.
Okay. Thank you.
Well, one other comment, Tom, is you're presenting this through the BayesNet side only, which requires this discretization of probabilities. And there's the other option that we're working on as well, to do this through an influence diagram where you don't have to have that level of discretization.
And that's this particular example is more of a Monte Carlo based situation where you've got you're basically entering equations, and this is like a universal soil loss equation that's taking in precipitation and the different levels of the option and generating a sediment yield based on an equation you enter here. And this is you can put any equation that R can solve in here. So it could be an R function call, but the idea is that you can anything R can solve has to have the right syntax. Then you can put the equation in here, and you can put so this particular parameter we've got a normal distribution on. So we've got a precip here too that's got a normal distribution. So you can input probability distributions and then various equations to relate the nodes. And then this is a simple core cover growth based on resedimentation model. So these are just deep-in models. And this would do a Monte Carlo simulation. So you have the choice of either doing a Monte Carlo simulation or a BayesNet. Anything else?
This is Katie.
Yeah.
I've got a question following up on this. Just one more time. I'm feeling a little slow today, but what does the influence diagram or the BayesNet get you at the end of the day?
Yeah, so
I think I'm having trouble tying it back into objectives or something, or how it all integrates.
let me go back to, let's see. So basically, you've developed a set of potential scenarios that you might implement, of a collection of options, and what you'd like to do is know which has the best weighted expected value, which is the optimal management scenario based on the impact of those options on your measures. And so what you end up with is basically a bar chart like this, where you're looking at which one of the scenarios has the highest expected value. And it turns out, in this case, it's replace the current monitoring stations with solar-powered stations. And so that's kind of the bottom line, is you pick the collection of options that has the highest expected value. And since you've developed the measures and the options from the objectives hierarchy, you know these are directly tied back to your objectives, and the way you value your measures and the way you've weighted your objective.
So if you wanted to, you could go back and change, like if you weren't sure on how you defined your whatever function it is with objective. Is it a weighting function or not? Either the weighting,
right? So this gives,
or the,
you can see the green bars in this little pop-up graph, and you can see that the flexibility kind of had a low weight, and the red would be the weight times the expected value. So it's fairly low for flexibility, but you see detect releases has a fairly high weight, fairly high expected value, and then when you multiply the weight by the value, it's fairly high. So so it's basically a weight time expected value calculation with with the weights and the values that tied back to your objectives. So really what you're trying to do is take your objectives and provide a quantitative engine for comparing different implementation strategies for alternatives or management options.
Hey, Tom.
Yeah.
This is Paul Duffy. I have a question. Is there a plan or a way to export the quantitative aspects of these types of analyses into something analogous to the type of export we do for like a gold sim model, so that we could assess the sensitivity of the outputs of various drivers that are, being like characterized by distributions in the model in the same way we characterize like KD distributions in gold sim?
Yeah, so the influence diagram has the GBM sensitivity analysis built in. So you get those same type of plots from a Monte Carlo simulation that we do for the PA work, the partial dependence plots and that kind of thing.
How important do you think that type of an analysis is to presenting and understanding the results to stakeholders with this type of thing?
I think the fact that we're translating everything to value allows you to interpret those plots in terms of value of information. So I think it's kind of easier to explain those plots when they're on a value scale, because you can say, well, if we reduce the uncertainty in this parameter, it's going to be equal to this much value.
Yeah.
So I think those plots are not particularly easy to understand, but once if you can explain them, there's a lot of valuable information in those.
Yeah.
Tom, along that line of sensitivity analysis, when you're ranking the objectives and laying out your measurement values, aren't you really determining the sensitivity then in a way by how you're valuing these things? For example, if cost was, you gave the highest value, then it's going to be most sensitive, right?
If you have a more complex model, like the previous example where we had the sediment model, it really tells you which one of those input parameters to the models are sensitive. And so doing the kind of sensitivity to the weighting factors is a different type of sensitivity that we need to work in. So you can basically assess how important different stakeholder weights might be in their impact on the decision.
So if you have a lot of values in this, how would you identify that? How would you identify the sensitive parameters?
Well, the sensitivity analysis methods we use are pretty good at sorting through a lot of different parameters and figuring out which ones are the most sensitive and what range of the measures they're sensitive.
Okay. Is that in here somewhere, or that would be a separate activity?
No, that's in the Monte Carlo simulation tool. It's an automatic output. I don't have anything like that right now in the BayesNet tool, and that's something we're kind of thinking about and working on now.
Okay.
The BayesNet tool doesn't set up uncertainty in the same way. And so that there's not really anything you can do that's exactly the same on the BayesNet for sensitivity analysis that you can do on the influence diagram or Monte Carlo side. We need to think of a different way of doing it on the BayesNet side.
This is Steph. Could you maybe say something about when you would choose the BayesNet version over the influence diagram and vice versa? I know they have some constraints, but sort of problem situations?
So there's kind of, well, if it depends on how complex the processes you want to include in the consequence modeling. You have some, like in a performance assessment where you've got some complex models with processes, if you've got KDs and radioactive decay and you've got animals and plants moving material, and you want to be able to handle those processes with equations, then you would use the Monte Carlo tool. If you're comfortable with a simpler representation of the probabilities, then you could use the BayesNet tool. The BayesNet tool runs a lot faster and can reason forward and backwards, so it has some advantages, but the disadvantages is you're dealing with discrete distributions and not continuous equations that can model processes.
This is Megan. I
So
have a follow-up.
you lose some information when you discretize. And for some things, you should discretize. But if you have a continuous function, you're losing some information by discretizing. So it's a balance, which is what Tom's saying. It depends on your situation, which might work best. But in the case of a PA, which is very complicated, that we might try to put in here in some form, but have to think about how to bring GoldSim into it, for example. But that PA is extremely complicated, has far too many parameters or variables in it. And we're thinking about using the BayesNet to screen that model and try to work out, well, what should really be included in the more complicated model. We'll see.
And we could build a BayesNet from the GoldSim realizations that is a simplified representation of the GoldSim model, and we could import that in as a BayesNet, and it allows some interesting, allow you to play around and do this forward and backward reasoning.
This is Megan. I have a little follow-up question to the discretizations. Do you have guidance or suggestions that you provide for doing the discretization or creating those categories?
So in general, we don't have good guidance for anything in here yet. And right now, the discretization is based on how you develop your value function. So this defines the discretization. And so, you know, if you have a good sense of how the options are going to fall out in terms of those these levels, then you can let that guide your discretization. We've also looked at doing a dynamic discretization from continuous distributions, so that it discretizes itself based on the relative importance in different areas of the distribution. So that's another thing we're playing around with.
So we did struggle with that at Hanford. At first, the value function that we put together wasn't tied sufficiently to the probability distribution on the costs. So the continuous value function at Hanford is a cost function, and Tom showed that. But originally, when we did this, there wasn't a sufficient connection between that value function and the probability specification. So we were getting results that didn't make any sense as a consequence of that. So it's a good point, Megan, that we really need to think about how to construct those better if we're going to do this in this way.
Yeah, that makes sense.
And soon we'll have another tab here that allows you to edit the value function when you're editing the node, so that you can dynamically update these categories, and that should help. It should help a little bit in defining an appropriate discretization.
Well, I'll have just one more
part
follow-up.
of the reason why we need more examples, more people trying this to see what works okay and what do we need to work on.
Yeah, and one of the things we need help with is the workflow and what makes sense, what's intuitive, what's not intuitive, and we're trying to get input from various folks that have used it and tried it, and improve the workflow. And each one of these tools, the part of the plan is to have each one of these tools live as its own web app. So we could have a value-focused thinking web app that is just about objectives and objective preferences, and then this BayesNet tool could live on its own as its own web app, as well as being part of the bigger GIST package. Any other questions? If not, we'll finish up. Our next webinar is September 1st, and I think Paul's going to talk about application areas and marketing ideas for GIST.
Well, I might lead a discussion on it. Let's see. So everybody on the call, think about that some between now and then.
Well, Kelly, are you on the call? Kelly?
Yeah, she is.
Yes, I'm here.
Okay. I think we have a little bit of time left. If you could say something about value-based thinking and some of the key things that you need to do in order to create objectives from stakeholders, how you translate their concerns and values into project objectives, which is all pre-software. I think there's a lot of pre-software work that happens that you do. Could you say a little bit about that?
I can, and really what I can talk about there is how we've been implementing the early steps in some of our cases recently. The Hanford example that everybody just saw was actually, we didn't get a chance to use GiST as it's designed, working with a project team to elicit their value judgments up front as much as we like to. But what we really, I guess, would prefer to do and have done in several cases now is gather together a team of stakeholders. Each project, of course, defines for themselves who they consider to be the stakeholders. So typically in the case of DOE, none of you will be too surprised to know that DOE considers themselves to be the stakeholders and kind of draws the line about there. EPA tends to go all the way out to members of the public, and anyway, you can define who you want to involve in the workshop early on. So we get the relevant stakeholders all together and ideally give them some background information on how the day is going to go and some little bit of training on just sort of value elicitation kind of discussion. But then the way this works as we apply it is somebody, and thus far usually Tom, is sitting with GiST open and a brand new project and is projecting it up on a screen in front of the classroom. And I just conduct a discussion with all the stakeholders about what matters to them. What do they care about? And I think Tom is good enough at taking cues from both me and the stakeholder responses, and I'm good enough at understanding when they say, well, we really like mom and apple pie, that I need to dig a little further and get them to, so I use techniques like the 5 whys and a little bit of fishbone analysis kind of work, and some techniques that we can talk about and I can describe more to folks, in a later webinar or in training someday. But to really get in and elicit from them some tangible means objectives, meaning not just the higher overarching mom and apple pie, but we really like a nice flavor of cinnamon in our apple pie, and we need to know that in order to have actionable attributes that we can work from. So while you could kind of do the part I do without the software, we actually are recording it in the software as that's happening so that they can see that the values that they are sharing with the group are being actively recorded into the project. Does that help, Pat? Is that what you
Yeah, I think I think it's good for you to keep us in touch with that, because it's such a critical step. I mean, basically, if that step doesn't happen right, the rest of it can kind of fall apart when you get into using the software.
Agreed. And actually, I think, I don't know if Tom still has that slide up. Paul's just going to bring it up for me. No, but when we talk about this webinar series, there's one coming up somewhere in the future about how each of us can be involved in the development of GiST. And one of the one of the aspects is this elicitation, both of the really qualitative values and objectives, and then getting into more quantitative elicitation of probability distributions. And those are two really unique skill sets that we need to be able to implement this. There are a variety of others, but like Pat said, that when we're looking at the software, it's easy to kind of forget that there's a softer side that goes with the whole thing. And
maybe we need to add elicitation training to this, but we were planning on doing it in January.
Yeah, so I don't think in these webinars we're not actually going to provide training per se, but we are going to talk more about what those skill sets are that we need, and sort of give everybody an opportunity to think about where they might best fit and want to contribute in the process, because it goes all the way from computer programming to sales and marketing to elicitation of probability distributions. There's just a wide range of things that are needed to make this successful. And that one that you're mentioning, Pat, is a tricky one, especially for a company full of introverts who don't really like getting up in front of people and making a fool of themselves.
Oh, that's good. Thank you, Kelly.
Sure. Well, Tom, if there's not more questions, you did record it today, right?
I did.
Fantastic. Folks, we're having a little bit of trouble with the size of the recordings. When people want them, it's hard to email them, but I'm hoping that by a week from now, Tom and I should have them up and available for everybody to be able to access. And so you'll be able to catch up on any that you missed, and we'll have another one 2 weeks from today.
All right. Well, thanks for playing along.
Thanks, everybody.
Thank you.
Thank you.